Welcome back everyone. Now to understand the flip-flop, I have written already the 3 points so that we can see the things and we can introduce the flip-flop and can invite ourselves to learn into completely new zone. Well, the first point that I would like to mention here is right in front of you. Memory element with the clock signal in the sequential circuit, or better said triple S, means sequential synchronous circuit. Well, um, this one. I have written that thing in this way. So I have written it triple S. Okay. So this is called as flip-flop. So when we add the memory element with the clock, that will become a flip-flop. What else we can have about the flip-flop? These are the binary cell capable of storing 1 bit. Like if you have stored 50 bit, you need 50 cells, each storing 1 bit. So this is about the memory. And now it can give the two possible output, normal value and complement value. Well, after learning this teeny tiny little thing, I would like to present you in front of you the flip flop. Let's write a basic flip flop circuit. Flip flop circuit. Well, when I was in my engineering, this was one of the most exciting topic for me because I learned that how the memories are actually working, and that excited me a lot. Well, if you think a deeper way, just for the teeny break of the topic, I would like to present you this one. So there is a capacitor and there is an inductor. If you charge a capacitor fully, it will discharge to inductor, and then that inductor again going to charge the capacitor. This cycle is called as memory in the practical world. But as digital logic design, we are not going to get into the details of the capacitor and inductor. We are going to get into the logic of it. So let's learn that how we're going to make it. Well, first thing first, a flip-flop circuit can be constructed using two NAND gates or two NOR gates. So now you get my point, that why I was saying again and again that the NAND, NOR, OR, and these kind of things were very important, and we have studied it extensively in the previous sections. So this is the thing. So I'm gonna use the NOR gate, and let's just make it, and let's learn something excitingly new from this one. So I'm gonna make it like this way. This is OR, and now it become NOR. And again, this is OR, and now it became NOR. I'm gonna push it a little for the output that we can see. And this is the first line, and this is the second line of the input. You can say I'm naming it RNS. Everything means something, we will learn about that, but for now you can just call it input lines. And the most interesting thing, well, I love this one and this one. Well, may let me change the color so that you can see the things and we can enjoy learning in a different hemisphere. Well, here it is, and if I change the color to the red, here it is. And the name for the outputs are Q for the first one and Q dash for the second one, means the complement of that. So how you are watching it? Okay, I just noticed that there is a little thing that I missed here. I'm gonna correct it. Yeah, now it's correct, because we wanted the two inputs, so we have got the two inputs. So these inputs, the white and red line input, are actually the output of its reverse. That means it is giving feedback. Well, we will learn about the feedback a little bit in the later one, but for now you can understand the feedback as the way we are getting the result of output, that how is it. According to that basis we can change our algorithm, we can change our design and can make more efficient things as per our requirements. So this is all it that I wanted to present you. And if you try to make it, you can make it in very interesting way. Well, we're not going to make it truth table, but I'm gonna present you few of the things. Like let's say that R is equals to 1 and S is equals to 0. So the value of Q and Q dash. Well, can you guess, my dear friend, that what will gonna be the value? Well, let's explore this thing. You just given here 1 and 0. Now, because of the inversion, that becomes 0, the inversion thing, right? And this becomes 1. Okay, but this is gonna become the feedback for this one, and this is gonna become the feedback for this one. So 0 0 becomes not 0, it will gonna be 1. Why? Well, this not is there, remember? So this is gonna be 1 and this will gonna be 0 because both 1. So answer must be 1, and this will gonna get invert again, and this will gonna give us the thing which is 0. Well, not from the 0 thing, this is coming in this way. Okay, even if you have not got it, that's completely fine. We are gonna discuss every of the flip-flop thing right after this. Okay, but in short and simple, our result is this one is 0 and this one is 1. So you can ponder upon this one. And let me tell you what is R. R is reset and S is set. So we call it RS. Well, we are gonna learn it in detail. Uh, here. Yes, we're gonna learn it here in a greater detail, and we will make it stable and everything that we're gonna see. So I would like to change its name. Well, it not make any difference, but still I'm just willing to do that. So I'm writing it RS. Well, what difference it make, you may ask? Nothing, just my comfortable thing. That's it, nothing else. Okay, so first of all, I'm making the AND gate. We are just directly getting into the design thing first. And here we have a NOR gate. And again, just one more AND gate. Let me make it and try it little beautiful way. So this is the second AND gate, and here we have it. Okay, now it's time for the connections that we gonna have. So why I said that this one is something the basic one and we're gonna make it, because as you can see we change it as per the requirements, and obviously we have not added the clock there, which is one of the most important thing. So we're gonna add the clock signal, because this is what gonna make it the real flip-flop. So this will gonna be our R, this will gonna be S. Well, you can write S and R, doesn't matter, seriously. I just wrote it in just for my fun way. So Q N plus 1. So this is the thing. And as we know that there is a feedback way that we can get. Okay, this one, the input of it. So this is all it. This is our RS flip flop circuit. So you just learned how to make a RS flip flop circuit. Well, interesting, right? Well, where you can use it, wherever you wish to. You can just experiment on that in particular way. For now, we're gonna see it's stable. Which stable? Well, as usual, it's stable. Clock QN SR, well, RSSR doesn't matter, as I told you. QN plus 1. So, what is Qn plus 1 is actually the next state, and Qn is the state. Okay, with all that said, let's draw the lines so that we can learn the things in a great way. Okay, so right here we are having 0 first, like the clock is not active, and then I'm gonna write 1 1 1 1. Well, I'll make more ones in just a while. Let's, why not just start everything right after. So this is not active, this is not active, this is not active, and this will not going to change. So this will going to remain Qn, or no change. Well, because of a simple thing, the clock is not active, so nothing is going to work, right? Now clock is active and everything is off. Well, 0 means off type thing that we are considering. So this become illegal state because nothing is active. What it has to do? It has illegal stage or step or whatever you like to call it. I am writing stage. So this is illegal. This is not legal thing. Okay, now we are just starting it up. So 0 0 1. So for 0 0 1, now it's gonna be 0. Now it seems logical, right? Okay, and in the next thing that we are gonna have is 0 1 0. Okay, let's write this table first so that we can understand the things quite clearly. 0 1 1, and then 1 0 0, and then 1 0 1, and finally 1 1 0, and then finally 1 1 1. I hope I have completed all the things, and the clock is active, so everywhere it's just a 1. Okay, let's see that we have done it correctly or not, so that we can count down the things. So this is 0 1 2 3 4 5 6 7 8. Well, I think I have missed something, so let's check it out here. 0 0 0 0 0 1 0 1 0 0 1 1, and then 1 0 0 1 0 1, 1 1 0, and 101. Okay, we will check that out later. Let's study this thing first. So what we're gonna have here is 1, then 0 or no change condition, no change, and then illegal stage will occur. Illegal stage, then 0, then 1, and then 1 means no change. So let me tell you one interesting fact here. Well, one interesting thing is when everything is 1, there is no change. When everything is 0, well, except the clock, one clock has to active, there is no change. Okay. Sorry, I wanted to present it here. Yeah. When the clock is off, it will not going to make any change. So these are the two important things that we have. And on the illegal stage, what is the illegal stage? Your alarm, your clock is active, but you're not doing anything. Everything is zero. And then about the zero thing, you are just active with the hour. You're just active with the hour. And your clock is active. Clock is gonna active for all the stages right after this. Just there's two possibility for the clock, off or on. So in the first case we were having off, and then after we are keeping it on all the time. And then when the one will going to come? Well, when s is going to be one. This is interesting, right? And now 011 case we have no change. Again there is no change. So what we are going to say in the no change condition, you can just think out a little bit, and I'm going to back you up in just a moment. And then we have 0 here, and then we have 1 here. This is all it, right? Okay, so what I wanted to present you is this one, that this is actually the output. Output. And this is the future of the output. Future of output. What is the future of the output means? Like if you have changed the thing, it will going to change. If you have not changed the thing, it will not change. You can call it, also call it as state. You can call it as next state. That's why we presented n plus 1 and n here. It means that it's gonna be the next stage. So sometimes the next stage don't change, like in these three cases it's not gonna change. Well, I explained the first 0th and 8th one, but in this case there is no change because both S and R are 1. So if you put both 1, you are gonna get no change. Like you set and you reset that what you set. So it will gonna no change. Just imagine a simple video game type thing that you set and then you reset. That's all what it means, nothing else. So sometimes you change, sometimes you don't change. And what's gonna be illegal? You off the both. You don't set, you don't reset, but still the output is 1, so it's the illegal stage. Same, if you don't set, you don't reset, that will gonna be 0, and that is also illegal stage. And when it will gonna change? Well, like in this case, in the third one, if you look at closely, you set but you don't reset, so it change, it invert the qn here from 0 to 1. And in the same way, if you reset everything, it will going to restart every game again. If you're playing the video game, you will understand it very clearly, you can relate with it. So it's going to change it. Now if you set but don't reset, remember I am using the negative negation like not, don't for the zeros, and for the yes for change, that's 1. Okay, so it was 1 previously and now you set, so 1 is there. What if you reset? If you reset, it will going to change. That's what happened, right? If you reset, it's change. If you don't reset, it don't change. This is all the way. This is all the way that we learn from the thing. Like a simple video game is there, and a stage is something like this, whatever you like to call it. If you set it, and you have a definite qn, so in the stage, in the next stage here I mean with when you start playing again, it will remain qn. And but if you reset it and it was qn, now it will gonna do the inverse because you reset everything. Now it's gonna start again, start again. So this is just a game, just that small little game that we used to play. So this is the thing about the memory and the SR flip-flop. I hope you have enjoyed it. Now it's time to learn the D flip flop. Well, I hope you have got the idea of the basic flip flop circuit and the RS flip flop and how you have actually made up the things. So, this is exciting. And after this, we'll see the D flip flop in the next one. Till that time, take care and God bless.